ozone depletion. Natural capital degradation. There's a massive ozone thinning over Antarctica. This picture was taken in 2007. Remember that your ozone is your natural sunscreen. This is the O3 molecule that is in the lower stratosphere, and it acts as your natural sun protection because it does block 95% of UV light from entering the troposphere. So what's problematic is that the ozone, it's not always accurate to say ozone depletion because it's just really in some places it's just thinning, and it's seasonal. So in October and November, this is found in Antarctica, and even in the Arctic, sometimes it's February to June. What's important to remember about this air mass is that these air masses don't always stay where they are. These air masses can actually travel. So they linger for a little bit over parts of the ones from Antarctica linger in Australia, New Zealand, South America, and South Africa, whereas the air masses that move from the Arctic, those go around Europe, parts of Europe, North America, and Asia. So it's not like they're just staying at the poles, but that's where you're going to see your seasonal depletion anyway. So basically what happened in 1930s, there was a scientist from General Motors. He was a chemist, and he discovered the first chlorofluorocarbon, and I'll tell you on the next slide what that all entails. But then in 1984, Rowland and Molina discovered that CFCs were depleting the O3. Now we knew that the that the ozone was being depleted simply because they were sending up weather balloons looking at those patterns, and they were looking at satellites and aircrafts, and that's how they figured out that the O3, that the ozone was declining. But Rowland and Molina are the ones that created a they called anyway for an immediate ban of the CFCs and spray cans. And the thing that's nice about it is that, you know, this is the only man-made greenhouse gas. Well, it's replaceable. There are other things that you can use instead of CFCs. That's the beauty of it. But CFCs were led by, they were actually created, the CFC industry was led by DuPont. You know, they're powerful, they're well-funded, so they had a lot of profits at stake and jobs at stake, so they were attacking Rowland and Molina's calculations and conclusions. But nonetheless, they continued their work, and they hired they got their scientists involved, elected officials involved, etc., and the media involved. And in 1995, they actually won a Nobel Prize in chemistry for their work there. So that was cool. So let's talk about what are CFCs. They are actually in a class called freons, and they're chemically unreactive, odorless, non-flammable, non-toxic, non-corrosive compounds that were used in refrigerants and as propellants in aerosol cans. And some other ozone-destroying chemicals. So it wasn't just CFCs, but you have the halons and hydrobromofluorocarbons that are found in fire extinguishers, methyl bromides, a fumigant, hydrogen chloride is found when this is released from the space shuttle when it launches, and then there's different cleaning solvents. So how does it work? Well, basically, under the intense ultraviolet light, and because of turbulence and convection and whatever, the chlorofluorocarbons were making their way over time into the stratosphere. And now these things are persistent. They last in the atmosphere for a very long time. So what would happen is that the UV light would basically break off the chlorine, the ultraviolet light, and then that chlorine molecule would attack the unstable O3 molecule, and then it would be able to do that, unfortunately, over and over and over again. Natural capital degradation, the effects of ozone depletion. The one that we talk about the most are the sunburns, the eye cataracts, skin cancers, and immune system suppression. But if that happens in humans, then you could think that probably is going to happen in other organisms as well. And then you want to also think about the phytoplankton, that it's going to disrupt the food chain. And if it disrupts food chain, the phytoplankton, then we're going to be in trouble because we're going to reduce seafood supplies because they're at the bottom of the food web. But we can reverse stratospheric ozone depletion, stop producing all ozone-depleting chemicals. Right now, and of course, it takes 60 to 100 years of recovery for the ozone layer to come back, because once again, even though we have this Montreal Protocol, the chlorofluorocarbons stay in the atmosphere for such a long time. So they had the 1987 Montreal Protocol that was passed and ratified that decreased the amount of CFCs, and they wanted to cut the CFCs down to about 35% emissions of CFCs between 1989 and 2000. But the seasonal ozone thinning was getting worse. So in 1992, they met in Copenhagen, Denmark, and they adopted the Copenhagen Protocol. And that one right there actually accelerates the phase out of the key ozone depleting chemicals. And so these were basically very important examples of global cooperation to the crisis. So they're hoping that the ozone levels will return to 1980 levels by 2068. And keep in mind, that's 18 years later than the original date projected. And hopefully to 1950 levels by 2108. So ozone protocol, this is an example of prevention. They're using prevention to solve serious environmental problems. And basically, the nations and companies had to work together. First of all, this worked because there was convincing and dramatic scientific evidence that there was a problem, and that CFCs were produced by only a small number of international companies. And then lastly, that since they knew for sure that CFC sales were going to decline over a period of years, this made them become more economic and creative, the private sector anyway, to find more profitable, suitable chemical substitutes. Here's the global average total ozone values. You can see that this is data is taken, this was given by NOAA, and this was taken from 1979 to 2005, and NOAA is the National Oceanic and Atmospheric Administration. But it shows the the mean total ozone level, and you can see that the numbers actually of the ozone level are improving, and especially since 1992, after the Copenhagen Protocol. Why should we worry about ozone depletion? Like, why do we care? Well, the damaging UVA and UVB radiation is very harmful for your skin and for your eyes. And then, if it's impairing or destroying phytoplankton, why should we care about that? There are two major reasons. First one is that they play a key role. Remember, phytoplankton, they go through photosynthesis, and so they are pulling, they're sequestering carbon dioxide from the atmosphere, and then they are the bottom of the food web. They form the base of the ocean food web. So if you destroy those, you might lose some vital ecological services that they provide. Also, I know kind of a separate topic is the global warming. That's going to make this even a worse problem because now you're not going to have the upwelling of nutrients anymore, but also support the populations of phytoplankton. So we're looking at another positive feedback loop. With that being said, hold out. The next slide will be, next topic is going to be on global climate change.